Okay, so everyone, today we do force diagrams. Force diagrams. Easy concept, but it will be the most important concept when we start actual what force problems. Okay, why? Because if your diagram is incorrect or lacking, the entire problem will follow a wrong diagram, and that means you will never be able to get the right answer. Okay, so force diagram. Okay, so whenever a problem that deals with forces is analyzed or discussed or studied, there are two types of diagrams that can be sketched for that problem. Okay, here's the good news about the two types. One of them I will never ask you to sketch. One of them, I will be asking you always to sketch, okay? The other kind, you can sketch it if you want. You don't have to. No marks will ever be given to it. But the second one, whether in first year, sorry, grade 11, grade 12, or first year, you cannot do the problem unless you sketch it, okay? So the first one is called what? System diagram. A system diagram, or short SD, capital S, capital D. And the easiest way to think about it is that it's your own painting of the problem. And please make sure that when I say painting, I am not talking about a fancy diagram. I'm just talking about like stick figures, quick thing. By the way, have we sketched system diagrams before? Yes, we did. Because we sketched what? Paintings of problems before, like when we did kinematics, right? A car moving. How did we sketch the car? We just sketched the what? A box with two wheels on it. That's as fancy as it gets, okay? So don't go insane with a painting, okay? So this one is the one I will never ask you for. The second one is called what? Which is one of the most important concepts in physics. Sorry. A free body diagram. You will hear this word so many times throughout this course, so many times throughout grade 12. And definitely if you go to science or engineering and you take physics, this will be a big thing every single time you do any physics problem. As long as the physics is like, engineering or normal physics, not classical advanced nuclear stuff. Okay? So free body diagram. By the way, called FBD. Get used to calling it FBD. Okay? So you will never be asked, well, at least by me, you will never be asked to sketch a system diagram. You'll never be asked. You want to do it? Go ahead. But I'm never going to put marks for it. The second one, as for a free body diagram, you will either be explicitly asked to sketch it, which means if you do the problem and you still get it right and you still do not show me for like 3 communication marks or whatever, free body diagram, you will lose marks for that part. I will force you to always sketch by saying what? Part A, sketch a free body diagram of the problem. Okay? Or you will have to sketch one anyway to be fully able to understand the problem. And what? Who can read this word? Yeah, everyone, we will never decompose vectors in grade 11. We only decompose vectors in grade what? 12. Okay? Grade 11, everything is perpendicular. Grade 12, any angle is fair game. Okay, so don't worry about decomposing vectors or breaking them down. But if you're gonna take grade 12 physics next term with me, almost every single force problem will involve what? Decomposition at some point. Okay, all right. So let's go to the next slide. Okay, system diagram. You are pushing a textbook to the right along a surface of a table. The question is, sketch a system diagram of the problem. All right, tell me what objects are mentioned in the problem. Table. By the way, do you need to sketch the whole table? Because the book is only touching the table's what? Thank you. So imagine if you sketch the surface and maybe a little bit of each leg and that's it. Okay, that's one thing. What else? Textbook. Thank you. Some kind of a pushing agent. Yes. Anything else? Or that's it? But is that a physical object or more like information? All right, let's sketch the objects first. So go ahead. So the only objects relevant are the textbook, probably the most interesting thing that gets moved. The table surface. I don't care about the whole body of the table. I just care about the contact surface. And then finally, the pushing factor, which is in this case, you or just your hand. Okay. So here's how I always sketch a textbook. The easiest way to sketch a textbook is to sketch a box and put some leaves through it. Done. That's a textbook. Okay. Which way is it being pushed? We're told to the right, which means the hand has to be here. By the way, what if it said pull to the right? Technically, then, by the way, the good thing about physics 11 and 12 is that whether you're pushing or pulling, it doesn't what? It doesn't matter. What matters is the what? Is the direction of the overall motion. Okay? All right. So here it is. Okay, that's go ahead. Just obviously you can only sketch up to here. Only sketch up to here. And here's the hand. Okay, how do you sketch a hand? I don't care how you sketch a hand. Just sketch a fist like this. Look, come on, come on. Done. Homer Simpson hand. Now, what is the only extra thing you can add to this diagram? Bahat, you said it. Tell me which way it moves. Well, in this case, there you go. That's it. Go ahead. That's your system diagram. There is absolutely nothing else you can add to this that would give you more value as far as physics is concerned. Okay, that was easy. Okay. All right, everyone. Now let's actually what? Go to the next one, which is the real, actual, important one in physics. Okay. So here's the problem. Is it exactly the same problem so far? No. Okay. Everyone, it's called the free what? Free what? Body, not bodies. You only focus on how many bodies each time? One. Okay? Which means I technically, by the way, I cannot tell you, listen, I cannot tell you sketch an FBD, free body diagram, of the problem. Because technically, how many objects are involved in the problem? No, involved. Three. There's a table, there's a hand, and there's a what? And there's a book. I always have to tell you which one to sketch the what? The free body. Basically, I have to choose the body for you. Obviously, 99% of the cases, you can tell which one is the most interesting object in the problem. Which one is the most interesting object out of the three we sketched? Yeah, is the table moving? Yet we could be interested in it. That's fine. Is the hand moving itself? Is it moving itself or is it moving something else? Which one is really under motion here? The textbook. So every time I have to tell you of the object. I have to choose. If I don't choose, please don't guess, although it's going to be very easy to know what I mean. Raise your hand and tell me which object do you want me to sketch the FBD of. I'll let you know. Okay, so obviously I have to sketch a textbook. All right. Okay, step by step. What are the forces acting on this object? Okay, so everyone, let's do them. Everyone listen up. This is the way I want you to think about it. Think of it in logically, and then in logical ordering, and then in pairs. Which force can you almost, as long as you're on Earth, you cannot escape? Gravity. Which way does gravity always point, no matter what? Straight down. Down to us would be just assuming the Earth is here and the center is there. Down. Okay. Now, is this book falling? No. It's supported by a what? By a table, which means it's pushing on the table because of gravity. It wants to rupture through the table, right? But it's not, which means what's canceling the effect? Has to be a what? A surface, which is what? Force? Normal. Do you see how I'm pairing them up? I'm pairing cause and effect. Cause and effect. Okay. Force number 3. No, hold on. Can you have friction? Is there friction on me right now? Is there friction on the table right now? No, on the table. Exactly. Once you instigate motion, you go against what? You instigate friction, which means you can never sketch friction first. You have to sketch what? Applied or motion. You have to sketch the agent first. Cause and effect. Cause means the reason, effect means the outcome. Okay? So we've done gravity, we've done normal, we've done applied, we've done friction. Which force apparently has no standing in this problem out of the 5 we've discussed? Are there any ropes or anything? I could add some, but you know what? As far as it stands, nothing. All right. Now, question for you, everyone. Where is the hand? In the previous diagram, where was the hand acting on? Like which side? Okay. Everyone, just so you know, a couple of things. Number 1, we do not care where the force is acting. We care which way is it what? Affecting. Do you see what I mean? By the way, in engineering, it's the opposite. They do care what? Which part of the object is being pushed by the what? By the force. I'll tell you why. Hamad, just step like just move a little bit to the just move back. Okay, everyone, what do I have here? A table. If I push perfectly, if I really push perfectly at the like along a line that cuts exactly through the center of the table, which way do you think the table would move? Straight. Would it wobble or go straight? If I really perfectly dead centered this one, it should move straight forward. What if deviated a little bit to the left, or well, to your left, my right, or the other way? Would it still move forward? But it will also what? It would also what? Turn. How about if I perfectly pushed right on the edge? Would it ever move forward? No, it would just what? But do you see how it matters where you push? Here's the good news about grade 11 or 12 physics. We never care which way you are, sorry, which point you're what? Actually touching. We assume, and this is important in physics, we assume that the entire mass of the object is concentrated exactly where? Right at the center of the mass. You see why? Do engineers do that? No. In first year engineering, actually, whether at Western or anywhere, but especially at Western, you will actually take a course called statics. Statics and dynamics. Statics means what? Nothing is moving. Dynamics means things are what? It matters then which way you're what? Where are you pushing or pulling on the object? Do you see me? We do not care. So that means what? The size of the object does what? Does actually play a role here, and the dimension. We don't care. We assume everything is just a what? A thin what? A thin? Thank you. A thin dot. Which brings me to my second point. In first year university, if you sketch the object, you get marks off. Because you're supposed to sketch just a what? Yeah, thank you. You cannot sketch the object as a what? As an actual what? Two-dimensional or three-dimensional. We assume that the whole mass is concentrated where? At the center. So what do you just sketch? A thick dot. And I only knew that. See, I didn't remember that from my first year back in '99. But when I taught a few students, like back in Weeble in 2010, and they went to university and they emailed me after, like, you cost us some marks in our first midterm. I'm like, why? What did I do? They're like, you taught us to sketch the FBD and actually sketch a what? Sketch the actual object itself. They told me all of us who did that on the first midterm, what happened? They got marks off on their FBDs because they did not sketch a what? A single dot. Well, here's how I feel about it. I like to sketch the object. Why? Because I then have a feeling of what? Which force is acting and why each force exists. But now you know. Can you do that next year? Or like you can. Okay. Again, it depends on the prof, but most profs will only require just to sketch a what? Just a dot, and that's it, because the whole mass has been what? Squished to a dot. Okay? All right. Which way does gravity act? Now, is it pushing from above or is it just pulling down? Okay. Here's the third thing about FBDs. Every force has to come out of the center of the object. Even if it's pushing on the what? On the side, it has to come out of the what? Center. Because we're dealing with vectors. I don't care where the vectors came from. I care which way it what affected. Okay? So which way is FG going? Straight what? Straight down. Okay, so everyone go ahead. What's the symbol for FG, by the way? Gravity, not gravitation. F small g, thank you. Am I forgetting something with the symbol? Am I forgetting something with the symbol? I don't need an arrow. Why? Are you telling me which way it points? Are you telling me which way it's directed? I told you, in physics, you're always going to sketch a diagram, which means what? You are implicitly and indirectly telling me the direction. Good. What reacts to FG? Yeah, I mean, if FG was by itself, this would not be standing. This would be what? Just what? Freely falling. But it's not, which means there has to be a what? A counter. Counter means what? Against. Counter force. What is it called? And what's the symbol? F. See, I'm pairing them because then I know exactly which one acts and which one reacts. Okay, which way is the hand pushing? It's pushing to the what? Because it's pushing from here, which means the force effect will be which way? Coming out of here and going this way. What should I call that force? No, I'm moving this way. Friction is against me. What force is that way? Applied. Okay, so we're just going to say what? F-A-P-P. What reacts to a force applied? Friction. And what was the symbol for friction? So for the force of friction, I mean. F, F, and I go with the subscript of small f. That's just my style. You can put two F's like F capital, F small under it, but make sure that one of them looks smaller than the other as a subscript. What's the last thing I could add to this diagram? Come on, what last thing did we add to the first one? The motion direction. Always tell yourself the motion direction. And that's what, by the way, that's going to be most of the FPDs we do in this course. 4 forces maximum. And do we have, what's the only angle between all of them? 90 degrees. I'm not going to give you anything to be broken down in grade 11. In grade 12, by the way, when you take grade 12 with me, you will become a trigonometry expert. Are we good so far? All right, easy. Okay. Let's compare the two. Let's compare the two what? The two diagrams. Okay. Can someone tell me a difference between the two? Come on. Tell me a difference between the system diagram. Again, they have a few differences. What can you think of? The system shows what? One or multiple? Okay, hold on. How many objects can you show on the system diagram? Multiple. How many objects can you show on the FPD? Good. What else? What did you show on the FPD that you couldn't technically show on an SD? Forces have to show on the what? Because we don't see them, but we know their effect. So that means you can't put them in a painting. What else? What kind of extra information did you put on both? Just the what? Did you put any kinematic stuff? Good. You're not allowed to. Everyone, in FBDs and SDs, you cannot put what? Give me kinematic words. Displacement. Acceleration. Exactly. You cannot. Thank you. You cannot put any of the what? The 5 variables that we studied. Okay, so let's go through them one by one. Go ahead. Multiple object, single body object, and that's it. Okay, what else? What else? This one, you cannot show what? That one, you have to what? You have to show all the relevant forces. By relevant, I mean, did I need to show the gravitational force on the textbook by the moon? Does it still exist? But it's completely what? Irrelevant and so small, it doesn't matter. All right. What else is there? This one has what? What about the other one? If anything, we need it with vectors, just like we did with what? With kinematics. Choose the positive direction. You guys see how we employ the same thing again. What else? Okay, everyone. Yeah. Yeah, multiple objects, single object. Okay, the other two differences, it's gonna look weird. Nothing on the SD. The other two are features of the FBD only. The first one is the forces must what? They can never point in, even though engineers make them what? Point in, because it matters to them which way, because which face of the body is the force acting on. Okay, what else is there? Oh, you cannot show kinematics. Okay. Now, after I told you all of the official differences, I'll come clean and say, I never sketch the FBD by what? By itself. You know what? Maybe it was when I took physics back in grade 10, like back in 97. But I think my teachers always what? They would sketch a what? And then on it, they would put what? Do you see what I mean? You would sketch the painting, and on the painting, you would put the what? You would again, that's my style. University physics should not be done that way. Do you see what I mean? You should not sketch a painting. Yes, you can only sketch the dot, and from the dot. So, you know what? That's why I don't like. In university, this is how a FBD looks like. Look. Looks like this. Looks like this. Okay, I agree. But by the way, does this look more physics or more math? That's the whole idea. Because we're employing what? We're employing what thing? We're employing what? Vectors. That's my point. So you only care about what? The directions and the magnitudes, and that's it. But to me, this has no what? No life. To me, I like to sketch a what? The textbook. And I like to sketch the what? And I like to sketch the what? Do you see what I mean? Because then I know what each force, what made it happen. That's not the way they want you to do it in first year physics. But I'm telling you now, so at least you go there and you're like, okay, I should be ready. I should not sketch a what? I should just sketch a what? I know, maybe you're gonna get a prof who's like easygoing like me. Sure. There we go. That's my point. I frequently mix system diagrams and free body diagrams. I sketch a system diagram first, and then I choose an object and put like a transparency, put all the forces on it. I know, to me, it just makes me see the system. Okay, so let me show an example of what I mean by both a system and an FBD at once. Do you have that already written? Okay, good, awesome. Okay, everyone, let's go to the next slide. Something like this. Okay, this is an easy problem. A box is sliding down, and what does incline mean, by the way? Like when you work out, what? Incline, decline. Incline means what? Technically above the horizontal. Decline means what? Below the, like when you do it in math, right? Angle of elevation, angle of what? Depression or declination or whatever. Okay? Okay. Question for you. Listen up. I want to sketch this. Yes. I want to sketch this as a system diagram. What objects are mentioned here? A box and a ramp. Okay. Hold on. Is gravity mentioned? But is it implied? See, I didn't ask what forces are mentioned. I asked what objects are mentioned. Only a ramp and a what? And a box. What's the easiest way to sketch a ramp? What kind of a triangle, probably? A right angle triangle. You do not need to sketch. I mean, who wants this? Who wants to sketch this as a ramp? Why? That's a 3D ramp. That's a ramp, right? That's a ramp. But if you guys sketch 3D, you also have to sketch a what? You also have to sketch a 3D what? You don't want to do that. Sketch a side profile all the time. Yes, Juman. Let me just finish this one because there's an idea in it I really want everyone to be here for. Okay. Okay, so I want you to sketch an FBD. Did I even explicitly ask you for the SD? I didn't, but I'm going to show you how I start with it anyway. All right, everyone? We can sketch a ramp and a box. All right? Done. That's it. How many objects are sketched here explicitly? 2. So to a university professor, this is not a correct what? This is not a correct FBD because it's free body. You just sketch bodies. You sketch 2 bodies. You can't do that. But you know what? I will let it slide for both grade 11 and grade 12. Okay, let's put some forces on. What's the first force you cannot escape? Which way? Down, you mean like this? But that's down. Prove to me that it can never. By the way, do you have any idea how many people do it this way? Because to so many people, they think when you tilt, yeah, the force of gravity is going that way. Is it? Prove to me that it's not going this way, it's not going straight. You can do one very small thing to the diagram to prove to, or to the situation to prove that it goes straight down. Second, if you suddenly, everyone, imagine if you suddenly remove the ramp. Would this box move, or sorry, fall this way? Which way would it fall? There you go. So that means what? Gravity always points what? Even if something is what? Tilted. It doesn't matter. You're still being pulled to the core of the earth. Okay. Tell me another force. What usually reacts to gravity, especially when you have a surface support? Normal. Which way does normal point? Okay. What? No, no, hold on, hold on. Hold on. No, no, hold on. What is the meaning of the word normal in math? Perpendicular. How would I hold this so that it's perpendicular to the surface of the ramp? Is this correct? Is this angle 90? How would I make it 90? There we go. Yes. Normal. By the way, wasn't that a question in your? That was a question in your quiz. What question was it? The normal force always points, and I gave you what? 4 options. One of them was what? Perpendicular. What was one of them? Always what? It's always up only if the surface is what? Level with the ground, not flat. Parallel to the ground. What was another choice? Parallel to the surface. Is the force pointing parallel like with it? No, it can never point this way. It has to point what? 90 degrees. Even if I tilt this, everyone look, what's happening to the vector? Is it moving with it? No, it's like is it tilting? That's my point. The angle is 90 no matter how the surface tilts. And I don't remember what the fourth option was. Okay. Now, which way is it moving? I'm telling you, it's what? Okay, if something is sliding down, hold on. If something is sliding down, what's slowing it down? So which way always does friction always act? With motion or against motion? Never with. It never pushes you forward. It always pulls you what? Backwards. So that means what? If it's sliding this way, which way is friction acting? It's basically like on the surface right here because of the roughness, and it's trying to push it, not push it, resist it back. Okay, 3 forces done. By the way, are there any tension forces here? Are there any ropes or chain? Nope. I could add, but nothing is added yet. What's the last force? Applied. Which way does applied force act? Like which way is it moving? So which way? Down. Okay. What's up? Damn it. You spoiled the surprise. Did I even mention anything about someone physically pushing the object? Then how come it's moving? Thank you. Gravity. By the way, is it under full gravity or partial gravity? Okay, everyone. Is this under full gravity? Assuming the air is not there. Yes, it is. Is this under gravity? Why is it partial? Because friction is taken from it, and also what's supporting? Do you see what I mean? Full means free fall. Partial means other players are mixed. So that means what? Why is this one moving? Because of what? Because of gravity. Still what? By the way, question for you. How come it's not moving? It's tilted. Gravity is in effect. How come it's not moving? How come it's moving now? What does that mean? Do you always get motion when you tilt? What do you have to hit? I had to reach what? A certain what? Angle. Does it make sense? What does the angle depend on? Question for you. Okay, everyone, think about it. If this was the most smoothed out surface ever, like by sanding it completely, like sanding paper, and you just gave it like a 2-degree angle, would it move? Yeah, because like you're on ice. What if this was a very rough surface? What do you need to keep doing? Yeah, because why? The little roughness is what? Is still what? It's still holding it, right? What needs to happen? You almost need to go all the way up to start what? So what do you always need? There's a sweet what? There's a sweet what? Spot angle. If you hit it, then what? Gravity beats what? Is it making sense? By the way, it's kind of a sad thing that we don't do any tilted ramp problems in grade 11. But in grade 12, almost every problem involves a what? A tilted ramp. Because then that's why you become so good in trig and vectors in my course. Because you get to practice every single day multiple times. Okay, so to today's point, is there an applied force needed? Could there have been an applied force? Could this have been a big ramp and someone is standing there and assisting gravity to push it down? But is it the case? What's the key word in the problem to tell you there is no applied force? Sliding. When you slide, you just need the what? You just need to hit the what? You just hit the angle. That means we hit the angle. Is it making sense now? So the forces are, which way does the gravity act? Straight down. From the what of the object? From the core center, yes. Right. Go ahead. Gravity 2 to Earth. Fg. What's next? What reacts to gravity usually? What's the pair? Normal, because there's a surface. Which way? No, no. Actually, everyone, friction is always what? Perpendicular or parallel to the surface? Friction. Friction is because of the surface, which means it has to act exactly with the surface itself. Good. Sorry, say again. They're not actually. Can someone tell me what's the angle between Fn and Ff? 90 degrees, which makes sense, right? Because if this one is pointed this way and this one is pointed anywhere here, what's the angle? 90. No, that's different. I'm talking about Fn and Ff. I am not talking about this angle or this one. Do you see what I mean? I'm not talking about this obtuse one or this also obtuse one. I'm talking about this one right here. Okay? Yes. What's up? Yeah. Let's think about this. Normal is always what? Perpendicular to the surface. Friction is always what? Inside of the surface, parallel. Which means what? By default, it has to be always what? Perpendicular to it. Okay? There you go. By the way, how many people are going to take calculus of vectors? You're going to learn basically that any vector inside a plane, any vector inside of a plane, like this one, or this one, or this one, or this one, or this one, and any vector perpendicular to the plane always have what angle between them? Is it making sense? Yes. A plane, all of it, is perpendicular to only one single vector, which is the normal. That's where the word came from. Okay? All right. Should I add this one? I want you to add it and then put what? Put an X on it. No, I need you to actually have it in your notes that we proposed it. We discussed why it's not needed. It could be there, but not in this particular situation. Pushing? What pushing? Since when did I mention pushing? I didn't. You proposed it. I said it's not needed. Things could slide as long as you hit the perfect critical angle. That's the name for it. It's called the critical ramp angle. Okay? Okay. Now I have what? A bunch of what? Demo problems. Let's sketch FBDs together. But in my way, which means what? What's my way of sketching an FBD? Sketch a what first? What's the other? System diagram, SD, and on it, imprint, impose, put, copy all the forces. Okay, everyone, come on. What's the question asking though? Draw a what? And also a what? By the way, if you looked at I think if you have well, I have like the solutions to this textbook, they would sketch it how many times? 2 independent times. One time for the what? SD, and one time for the what? No, we combined them together. Okay, what's the first one? By the way, why is this one written in italics? Because that's the what? That's the body in the free body diagram. Okay, a book is what? A book is at rest. Keep going. On top of a desk. Okay, what are the objects interesting here? Sorry, what are all the objects mentioned here? Desk and book. Okay, everyone, we don't need a lot of space here, so let's divide the rest of the slide to 3. So let me just tell you what I mean. Come on. Okay, so let's divide this into one side here and one side here, I guess. Let me just make it bigger. Okay, how would you sketch a surface and a book? What did you just sketch? Thank you. Line. By the way, okay, everyone, are we told anything? Listen up, everyone, guys. Are we told anything about the book moving? No, we're told it's at what? Okay, what if it was moving? Are you told anything about friction being negligible? By the way, everyone, watch out for, there's a lot of questions at the beginning. You always assume that friction is what? Friction is what? Very what? Very small. Yeah, always get used to this phrase. Friction is negligible. What does negligible mean? Negligible mean neglect. What does neglect mean? You don't care about it, okay? Or neglect friction. But when you really want to make an accurate system, what do you have to do to friction? Neglect or consider it? Are we told anything about this surface being super smooth? No, you're not. So even though friction is not really in play, I want you to sketch what? Everyone, eyes on me. Yeah, please sketch. Don't sketch it perfectly lined. Make it a bit curvy. Okay. So go ahead. Here it is. And here it is. Okay. What's the first force by default? Thank you. FG. What reacts to it to prevent it from falling? Any tension? Any applied force? Any friction? Not unless you're moving it. Done. Yes, thank you. Friction is only a motion caused effect. Okay, next one. What? A basketball falls through the hoop. Ignore what? All right. By the way, if something is falling, which way is air resistance swishing around it? Up. How about if you move it up? Which way is air going? Air is friction, which means it's always going against the way it's moving right then and there. Okay. So what objects do I sketch? Basketball. And are you told anything that it's touching the hoop? Does it say? It falls through. So as far as we're concerned, there is no contact between what? The ball and the rim. Thank you. So here's the rim. Here's the net. You see? You see? That's just sketch free over years. You're like, gets there. Where's the ball? Right in with, yes, exactly. So the ball would be technically, okay, it's not touching the rim. It's not touching the mesh of the net. What's the only technical force on it if we neglect air friction? Gravity is the only force that is bringing it down. Is it moving? Which way is it moving? There you go. Add a motion direction and just put motion. I agree with you, but what did they tell me? They said that. By the way, in general, everyone, unless they say it, you can't what? You cannot ignore it. And if you're ever in doubt, let me know. Okay, next one. What do we have? A large trunk, like a dresser or a big box, is pushed horizontally from behind towards the east across a rough floor. All right. So what objects do we have? We have a floor, and the floor is what? Which means definitely what exists? You got it. And a box, and it's being what? All right, I guess I'll sketch another hand. Okay, so rough surface. Which way is it being pushed? So I guess we will assume it's going that way. Yeah. And the hand again. Okay, force number one. Come on. Gravity. Down. Force number two, reacting to gravity. Supporting the system. Thank you. Normal. What's causing motion? Causing. Applied. You're applying a force. You're applying a force. So FAPP. There's a rough floor. Friction. By the way, everyone, I guess it's my habit to really be a very visual person. I like to sketch them where they actually exist. Where does friction actually exist? In the middle of the object or on the floor? So you're gonna see me a lot of times, not every time, sketch it where? Yes, like around the floor. Oh no, I agree. Again, you said it. We assume everything has been what? Compressed to a dot, but I like to give it what? A physical feel. That's all. Yeah, but obviously, when you do it as a vectors, you assume there's no size to the object and it's just a thin dot. Yep, you got it. So F. What's the direction of motion? By the way, could this object ever move to the west? Why not? There's a force pointing to the west. I agree. But what if one force? Okay, Yasmin. What? Okay, Yasmin. What if I pull on you this way, and Maryam pulls on this way? You can exist in how many? One of how many cases? Three. If we are identical in force, you should what? If she's stronger, if I'm stronger. So my question is, hold on, hold on. If the applied force is bigger, definitely, which way would this one be moving? What if friction is bigger? Thank you. The problem with so many people, they think is what? Once one vector is bigger, it makes it move that way. Does it? Is there any way this object will ever jump west? What's the worst that could happen? Okay, if this one is bigger, what's going to happen? What if this one is bigger? Either it wouldn't move or it would what? Slow down if it was already in motion. You see what I mean? But would it ever slow down and then suddenly start moving your way? No, because friction is what? Friction is not an active force. What's the opposite of active? Passive. It's a passive force. It reacts, but it never acts. Make sense? Never. Good. Nice. What am I missing from here? The motion direction, which the only way here, it's either none or it's being what? It's being pushed uh, towards the east. By the way, technically, even if it's being pushed towards the east, is that a guarantee it's in motion? No. I'm pushing. Everyone, am I pushing? I am, but it's still not what? Now it is. So you know what? I know it doesn't say. Let's assume it's in motion. Okay, what's up? Yeah, go ahead. So go ahead, everyone. Motion. I like to put it on top of the diagram. Nice. See, you're putting everything to a visual now. Yes. Yes, absolutely. Okay, everyone, let's do this one. Okay. Because there are four options here, that's why I give you this slide and another slide to do it on. A car is parked on the road. Parked. Straight line. Thank you. So everyone, let's do A here. Okay. So car. You want to sketch a car? Fine. Here's my car. Car. What's pulling it down? Gravity. Pushing it up. You see, that's what engineers care about. Everyone, is the normal force actually pushing on the body of the car? No, it's pushing on the what? The wheels, the tires. Engineers would actually give you a force up here and a force. Do you see what I mean? They care about the actual point of contact. Yes. Next one. A small fish is hanging from a fishing line. What new force are we going to introduce now? Tension, because a line is basically like a string. Okay. Oh, hanging means, is it sliding down, sliding up, or just keeping its position? Okay. All right. Uh, it's hanging. It's hanging. It's everyone. It's hanging. Everyone, is there air swooshing around the tablet? No, no. Consider it's not moving. How about now? How about now? There you go. Thank you. It's these little details. Okay. So for part B, how do you sketch a fish? And what's connected to the fish? The hook. Yeah, the hook. So as far as concerned, sorry, my bad. What's up? I always sketch a rope, with the line. ايش حكيت؟ Okay. Which one do they listen? Which one do they want the FBD for? The rope or the fish? The fish. I mean, what's so interesting about the rope? It's the fish. What's acting on the fish? Gravity is pulling it down. And what's preventing it from going down? And what force is in ropes? Tension. What symbols for tension? But come on, there's an easier one. No. Capital T. Trust me. don't use FT. Just say it capital T. And where do you put it? It doesn't have to be coming out of the center. It could actually what be pointing straight like this. Done. By the way, everyone, look, listen up. You know why I don't like to put tension inside of the object? Because technically, who's under tension? The fish or the rope? Yeah, who's being stretched? Not the fish, the rope. That's why I like to put it physically where it belongs. Any motion here? No motion, which means nothing else. Okay. Baha, what's question C? Football is flying. Okay. Falling or flying? Falling. Okay. Even though, by the way, everyone, listen up. If something is falling, does that always mean it's falling straight down? The whole time it was falling, which means technically it could be going down at an angle. Okay. Does gravity change its way on it as it goes up and down? No, gravity always pulls what? What changes around the object? The air, the air friction. If it's going straight up, air goes this way. If it goes down, air goes that way. What if it's going this way? Air is always going what? Parallel in the other direction, right? If it's going this way, air is pushing, not pushing, pulling, resisting this way. By the way, why do you think like a ball changes its direction? Because the air what? Slows it down, and then it goes this way. All right, so 1 second. So everyone, I'm gonna sketch it. They didn't say. So let's say here's the ground and here's the football. What's up? Oh no, I'm just because it's falling towards the player. That's all. Which way? 1 second. Which way does FG go? Down. At this moment, if it's going this way, which way is friction going? With or against? So everyone, technically, motion, which means friction is, what am I calling friction here? F what? Yeah, I don't want to call it F friction because we're never going to deal with air drag anyway. We're only going to deal with surface friction like this. So I'm just going to call it FF for now. What's up? Okay, everyone. The last one is your homework, and I'll post the solutions today.